Okay.
Exam 1, because all the price controls are under exam 1 for clinical too.
Okay. And that is.
JT asked me. He told me that you had said
So
it was
okay.
Okay.
So I'd forgotten what it was, who was on the other end, but I'm seeing me. Right?
Oh no, this is a recording actually.
So if it's recording, that's fine. If it was Skype, it's malfunctioning.
Okay.
Okay. Okay. So I'll go through this, and the point of this is for people to stop and ask questions. Okay. So please do if you have questions. Okay. So this is a good one to pick because of a couple things. First, it reviews price controls, which people are rusty on. Second, it reviews elasticities. And the third is that it reviews computing CS and PS. So it's a very good one to practice on. So if I were going to tackle this, the first thing I do is I'd start out by just drawing a graph with the information as it was given in the problem. So what I know is there are 100,000 people working and they're getting $8 an hour. So I know 1 point. And the problem says that that's an equilibrium to begin with. Okay, so I know that's where the curves cross. And then I can fill in from about the supply and demand curves because I know the elasticity. So I might sketch it out like that. So I'm using the information that I have the original equilibrium, or I have the original number of people in the market and what they're paid, and that it's the equilibrium, so now it's where the curves cross. And I've just kind of sketched in their elasticities approximately. Okay, so far so good? Okay, so but the main point is that when you do the problem, before you worry about what the price control does, just figure out how to draw the diagram with the equilibrium. All right, now I come in and I say, minimum wage $10. Okay. So in principle, the first question to answer is the minimum wage binding? Okay. Is it actually higher than the existing wage in equilibrium? And here it is. Okay. The minimum wage has been 7. First you worry, and then you think maybe all of your birthdays came at once, because if the answer is 7, if the minimum wage had been 7, what would the answer be?
That it's not binding.
Yeah, not binding. Game over, no analysis needed. But alas, this one is binding. Okay.
Would that ever happen?
It would happen. Okay.
On an exam.
So I wouldn't do it on purpose.
Okay.
For various reasons, one of which is that if I actually did that on purpose, you guys would spend 45 minutes trying to figure out what you'd done wrong because you would be sure I'd meant it to be binding. Okay, so I wouldn't do that on purpose. Because I write a different exam every time, there's some remote chance that I will make a typo. So like you should look and make sure that it actually matters. But you can probably expect it just price control over binding. Okay, so the price control is binding. So the next thing to do, if you're rusty at this, is you have to figure out what the price control in binding actually does in the market. And if it doesn't instinctively come to you right away, the thing to do is to look along the price, either the minimum wage here or if there's a ceiling. And whichever curve it hits first is going to be the thing that controls the market. Right? So in this case, it's going to hit the demand curve first. So the new market Q is going to be the number of workers that people are willing to hire at that wage. And what happens after that, out here, is for the purpose of this kind of exercise is irrelevant. Okay, because This is a market with voluntary exchanges. Once the employers have hired this number of people, the fact that a lot of additional people would like to work is not going to matter in the welfare analysis out here because they're not working. They're not working, there's no surplus. Okay? Okay, so the next step is to figure out what Q2 is. Okay, so we figured out that there's going to be a reduction, and we just need to find out what Q2 is. So to figure that out, if you're rusty and you want to be very systematic about it, what we do is we just look at where the original equilibrium is and where the new equilibrium is, and look at which curve the 2 points lie along. Okay, and here they lie along the demand curve. So I can figure out what happened by looking at the demand elasticity. Okay, so we use the demand elasticity, and I know that the price is going up by 25%. Okay, so I know I got 2 points along the demand curve, so that's why I'm using demand elasticity. I don't know the percentage change in Q, that's what I want to find. But I can figure out what the percentage change in price is, because that was actually the purpose of the policy. Okay. So, so I could use the elasticity formula and the percentage change in price to work out the percentage change in quantity, and it's a 12.5% drop. So there's a 12.5% drop on 100,000 people. That means 12,500 people lose their jobs. Okay. And the new Q2 is the difference between them. Which is 87.5. Okay.
Is that what the question asked?
Well, the question, I was stopping to get some gauge about whether what I'm saying is, so no one is saying anything, and that means either this is totally obvious and you want to go into a different problem, or you don't have any idea what I'm talking about, or something else. And I'm trying to figure out which one of those it is.
It's there.
Very clear. Okay, so 8.7. So that's the new. So the problem says what's the new number of people working, and it's 87,500. Okay, and then the next step is to do the CS and GS calculation. Okay.
So what does the question ask? I'm sorry.
The question says, what's the new amount of employment, which is what we just answered, and then it says, please calculate the welfare changes in consumer and producer surplus and what's the overall social surplus. Okay. All right. So for people who are rusty at price control problems, this is where where you have to be careful. So So, we can calculate the change in consumer surplus by looking at the old price and the old number of people who went to work, and comparing that to the new price and the new number of people who go to work. And then looking at the change in the surplus the buyers get out of hiring all those people. Okay. So that's the trapezoid. Okay, and so to calculate it out, you just deploy the trapezoid formula, and that will give you the number, which I can calculate. Okay, and that's a loss, because price went up, money went down. Questions?
Why did you write it like that when the twos cancel out?
I wrote out the trapezoid formula, and then, because this two conceptually is different, right? This one is just.
Right, yeah,
But
gotcha.
that's the two
That's just
there.
coincidence.
It just was coincidence that it happens to be 2 and 2. Okay, so the producer surplus is the next piece. Okay. So that's the original equilibrium. The new Q is 87,500 people. That's what we found here. And the amount they're paid is 10. Okay. So price control problems, both price ceilings and price floors, always have this complication that one party has a very straightforward change in surplus. The other one is a little bit involved. Right? So here, the old PS was that area, just adding up over all the people that were employed on the surplus they got. The new PS, we do the same thing, we add up over everybody who's working, the surplus they get. Okay. And the only real wrinkle in these problems is that you have to remember that in this case, it's not the difference of two triangles. More complicated thing. And so when we go from the old one to the new one, the sellers, the workers, gain area A, but they lose area B. And area A is really easy to calculate. That's just 2 times 87.5. 175,000. And then B. Okay. What's the tricky bit with B? Melissa?
You need that, like, hypothetical price,
Yeah.
that's under $8.
Yeah. So we know one side of the triangle is $12,500, but we need to know this side.
So you use the supply elasticity?
The supply elasticity, exactly. So we need to find X so that we can figure out how big that side of the triangle is. points on a single curve, and this time it's the supply curve. And here, what we know is the percentage change in quantity. Okay? So this is one of the cool things about these price control problems, is that they're linked together in a very distinctive way. So we know going from here to here, we know the percentage change in the quantity. What is it?
12.5%.
12.5%, right? It was actually the answer to the first question, like how much does the quantity change? So, okay, so what we're doing now is we're saying, essentially, what would the change in price that the sellers receive have to have been to cause a 12% decline in the number of people who are going to work? Okay. And so, in this case, because the elasticity is 1, you can just see multiplying through by percent change in P that you get that. So we would have taken a 12.5% reduction in the wage to get the same drop in people going to work. Okay, and so the change in the price is the original wage times the percentage change, which is minus 12.5%. 12.5% is just equal to what? In fractions. It's equal, this is just equal to 1 over 8, right? So, okay. So what that says is that to have done the same thing, you get the same change in employment by decreasing the wage, it would have meant having to reduce the wage to 7. Okay? And now we have all the information we need to calculate area P. Okay, just 1/2 of 12,500 times 1. Any questions? Total values?
625, right? 6,250.
The actual number is, yeah, okay, so the sellers, in this case, end up better off. Minimum wage helps the sellers as a group. And then the total change in social surplus is just the sum of the two pieces. Or a loss of a little under $19,000.
Since it's been a while since we've done this, I can't remember any other variations of this problem. But for this exam, will you ask just these 2 types of questions, like the change in employment and then the surplus?
Well, okay, so that's a good question. So all told, if you were prepared to do 4 different kinds of analysis, you would be fine. So one would be a price floor, like a minimum wage, something like that. The other is a price ceiling, like a rent control, or possibly like price control on gasoline. So I wrote an exam after Hurricane, I forget whether it was Katrina or Sandy, there's a lot of hurricanes, when people were proposing gas price controls. So you might see something that looks like a price ceiling on gas. It's the same thing as a price ceiling on rent. So you can either have a minimum price or a maximum price. And then the other dimension is it could either be an elasticity form or it could be an algebraic equation form. Okay. But basically, the way the analysis always goes is the same. You look at what the market equilibrium would look like. You look at what the world looks like with the price control in effect to see whether it's binding or not. Okay. And then you figure out what would happen if you either imposed the price control when it wasn't binding or you got rid of it if it was already there, and you do the welfare analysis. Okay, so if you practice one that's a floor, like a minimum wage and elasticity form, and one that's a ceiling, like a rent control, that's an equation form, you'd be pretty well set.
And you should have an equation form, like an algebraic form.
Yeah, like there's someone there that said the willingness to pay curve looks like this. And
what's the main driver of the size of area B? I'm just trying to think about it in terms of like elasticities, or I just don't know which one would make that. What would make it a bigger loss rate?
That's a good question. So what happens? So what happens is with the minimum wage. So we'll talk about both. With the minimum wage, because the binding constraint on the minimum wage is the buyer side. You impose the higher wage, it's the buyers who are determining how many people are going to work. Their supply elasticity determines the drop in employment. So if employment drop, so this piece of B, the number of people who lose their jobs, is determined entirely by the demand elasticity. It's all happening on the demand side. So that's half the answer. The other half of the answer, so economists are always good things about saying on one hand, on the other hand. And this is not one of those. There's two halves of the answer, but they come from the same underlying thing. So the other half of the answer is that part of what determines how big B is the supply elasticity. Because if the supply labor is really elastic, area B is going to be really small. You know, if the employers cut back a lot of people who were kind of indifferent about working, there's not a lot of loss. On the other hand, if the supply elasticity is really low, and if people really want to go to work, then area B could be really large because you're cutting back on employment, and there are a lot of people who really want to work at that wage. They lose a lot of surplus if they lose their jobs. So area B is actually affected by both. One affects the quantity, and the other affects this side, the supply elasticity, and this side, the demand elasticity comes out. With the price ceiling, the comparable piece is also driven by both elasticities, but the logic goes the other way. The supply elasticity determines the quantity.